Continuing on with our conversation about the standard form of a quadratic equation, we're talking about this: y equals a x squared plus bx plus c. Now we're interested in sort of solving these things, okay? And when we say solving, we're looking for what we call the roots of the equation, or the zeros of the functions, or solutions. Okay, these are all various names that essentially mean the same thing. It means we're looking for the point at which these quadratics cross the x-axis. So we could also refer to these as the x-intercepts. So here's the graph of the function y equals x squared minus 4. Okay. We're interested in 2 points on this function. We're interested in this point here and this point here. These are the points that we call the solutions, the zeros, the roots. And to find those, we're interested in where they're crossing the x-axis. So we need to realize something about y at the x-axis. Y at the x-axis is 0. So we can write this, if we're interested in what's happening at y equals 0, we can change this equation to be 0 equals x squared minus 4. And that gives us two options for solving. We could look at this as a factorable opportunity. This is difference of squares. So we have 0 equals x minus 2, x plus 2. Okay, and we know to make x minus 2 equal to 0. So with the 0 property of multiplication, we can make this 0, and we can make this 0, which would result in making the whole thing 0. So to make just this portion 0, x would equal 2. And to make just this portion over here 0, x would equal negative 2. So those are our solutions, our roots, our zeros, 2 and negative 2. We could also do it algebraically. We could say that x squared without factoring. We could say that if x squared minus 4 equals 0, add 4 to both sides, and we get x squared equals 4, the square root of x squared therefore would equal the square root of 4, which means x would equal 2 and negative 2, because 2 and negative 2 are the square roots of 4. And negative 2. So for all of these problems, we're always going to be interested in those points where y equals 0. So just keep that as an overarching note for all of these problems. Y equals 0. We're interested in the points where y equals 0. And a lot of the equations they offer you, they're going to have it already set up to 0. And you want to think about, can I factor this, or can I solve this algebraically, so on and so forth. Let's look at this equation. X squared plus 1 equals 0. Okay. If you graph this, you're going to notice something interesting right off the bat. But let's assume for a moment we're not going to graph it. And let's think, okay, what would the solutions to this be? Well, if I look at it and try to factor it, I recognize that it only has 2 terms, but it's not difference of squares. So I can't factor it. Okay, well, let me try to solve it algebraically. I'll subtract 1 from both sides, and I'll get x squared equals negative 1. Square root of x squared, square root of negative 1, x equals the positive or negative square root of negative 1. We don't have any real numbers that can satisfy that. So this, we would say, has no real solutions. Actually, we should include the word real. No real solutions, okay? So be aware of those types of problems. They will come up in this. Not all of them, but there are going to be a few where you're going to go through the solving process and you're going to realize, wait a minute, this doesn't have any real solutions. Okay, so keep an eye out for that. Most of the problems you're going to face tonight, though, can be factored or can be solved algebraically somehow. It doesn't mean they're all going to come up with integer answers. What I mean by that is you may come up with something that is a decimal or a fraction. That's okay. Okay, don't worry about that. But just pay attention to whether it does come up with an integer or whether it comes up with something impossible like this, where there's just no solution.